So I'm recording this on a Tuesday. Your test is next Wednesday. Most of you will not watch this until the 16th, and that's on you. Little things like do not blindly copy. Do not blindly copy. Learning requires you to, the hard word, think. It does. Don't just be sitting there copying. So when I look at number one, it's about this rule that you've memorized, x to the power over the root. It can be written as the rth root of x to some power, or even better, the rth root of x all raised to that power. So when I think about this mentally in my head, what I'm doing is I'm taking the cubic root, that's a 3, of 27, and then I'm going to raise it to the 5th power. Now, the cubic root of 27 is something we've done in class on a regular basis. That's a 3. And then I'm going to raise it to the 5th power. And believe it or not, this is something you can do. That's 3 times 3 times 3 times 3 times 3. Put those together, that's a 9. If I put those together, that's a 9. That's an 81 if I multiply. I multiply by 3, and by God, I get 243. It's not unrealistic for you to do that. It's not. It is, you probably shouldn't be in Algebra 2. It's not unrealistic for you to be able to do that. All right, we have a simplification problem. Simplify the cubic root of 4x to the 7th times the cubic root of 9x cubed y cubed. So let's do a little bit of math here. You have a property that says the nth root of a times the nth root of b is the nth root of a times b. I'm allowed to multiply these things together. So inside my cubic root, the product of 4 and 9 is 36. The product of x to the 7th and x cubed is x to the 10th. And then there's this y cubed guy. Okay, well, let's look at this piece by piece by piece and see if there's anything we can do with it. My cubes. 2 times 2 times 2 is 8. But their 8 is not a factor of 36. Your only real factors of 36, and they're not numbers that you can take cubic roots of, like 36 divided by 9 is 4. I don't know the cubic root of 9, nor do I know the cubic root of 4. I could also divide it by 2. I'd have an 18. You can't take the cubic root. So there's literally nothing you can do here with the cubic root of 36. This x to the 10th, though, I can do stuff with that. Okay, so one of the ways you might look at that is you might look at it as the cubic root of x cubed, x cubed, x cubed, x. Now, every one of those cubic roots of x cubed is an x on its own right. So what I'm going to get when I evaluate this piece right here is x, cubic root of x. Now, x is x cubed, okay? I also have the cubic root of y cubed, which is just y. And stuck inside that radical is that 36, which I couldn't do anything with, and this lonely little x. One way you might do it. All right. On number 3, you can only add like terms. That's all you can do. You can only add like terms or subtract. So I have to force these two things to become alike. That's what I have to do. And is that something I can do? One could hope. So let's take a look at this first piece. 48 can be broken down into the 4th root of 16 times the 4th root of 3. Now I can take the 4th root of 16. The 4th root of 16 is 2. So I already had an x, 2x, 4th roots of 3. Now I'm going to work on this one, okay? Doesn't look like I'm going to be able to do anything with it. The 4th root of 81 is 3, and the 4th root of x to the 8th is x squared. So when you simplify this one, this is as far as it goes. Now, if I lost you on this, the 4th root of 81 is 3, okay? The 4th root of x to the 8th, think about your p over r notation. That's x to the 8 over 4, which is x squared. So that's as far as that one simplifies. 2x, 4th roots of 3 plus 3x squared. Number 4, convert that thing into an equivalent radical. That could be bad. I can tell you right now that the wrong choice, which I would put on a test just to see who picks it, the wrong choice would look like this. It'd look like the 8th root of 9x to the 7th. That is wrong. It's 100% wrong because 9 has its own exponent. Now, because 9's just sitting there chilling by itself, it does not need a radical. It is 9 to the 1st. The radical would be the 8th root, and the power would be the 7th. Or I might write it like this. I don't know how I'm going to write it. I don't remember. But either one of these two are correct. This one is wrong every time, so do not be that child. Don't be that student. Radical simplification's up next. This is going to get a little iffy. All right, we have to do something. We have to use the conjugate. I was a little disappointed in first period this morning how many kids couldn't form a conjugate. So the conjugate of 3 plus root 5 is 3 minus a root of 5. And if you multiply the bottom of a fraction by that for equality purposes, you have to multiply the numerator by that, okay? So we got to do 3 plus root 5 and 3 minus root 5. For the video purposes, I'll probably just do a box, a little bit slower, but, you know, whatever. I don't care. You should FOIL it. 3 times 3 is 9. 3 times the root of 5 is 3 root 5. Negative root 5 times 3 is minus 3 root 5. And then negative root 5 times positive root 5 is minus 5. And you see those two cancel. 9 minus 5 is 4. So the bottom becomes a 4. Up top, it's not going to look any prettier than it is. It's actually going to get quite a bit uglier. You got 1 minus a root of 2. And you got your 3 minus root 5. But again, it's the this is what it stems on, is the conjugate. 1 times 3 is 3. 3 times negative root of 2 is minus 3 root 2. 1 times negative root 5 is minus root 5. Root 5 times root 2 is root 10. A negative times a negative shall be positive. So the top is just ugly because nothing in here is alike. It's 3, take away 3 roots of 2, take away a root of 5, and then add in a singular root of 10. And that's as far as you can go with this thing. So that's where she stops. Not necessarily a hard problem, but that's where it stops. All right, where am I at? I'm at number 6. I want to say something about number 6. And I mean it quite honestly. Only the lowest students should miss this. Plain and simple. The lowest students should miss this. Only. So if you miss this, there you go. All right. 25 over 5 is a 5 up high, because the 25 divided by 5, we'd have a 5 up high. I'm going to move exponents. You've got this rule about x to the negative n being 1 over x to the n. If an exponent's negative, it's on the wrong side of the divisor. So I already had an x squared down low. I'm going to move that x to the negative 5th and makes the exponent positive and bring it down low. I've got a y to the 6th up high, and there's nothing down low. This guy is also going to get moved, and if you move it to the other side of the divisor, you change the sign on the exponent. And then I'm going to combine like terms. Let's see here. There's nothing to do up top. Down low, we add exponents, right? X to the 7th. Easy peasy lemon squeezy. 7 is going to be a hard one. My goal, I hope that 1/2 get correct. That's my goal. I hope that 1/2 get it correct. Because it involves thinking about a goal. Okay, so my goal is that the denominator becomes the cubic root of 27x cubed. Because I know how to take the cubic root of 27, and I know how to take the cubic root of x cubed. And I can't take the cubic root of 9, I can't take the cubic root of x squared, but I'm going to start there. First off, I'm going to break it apart into its two distinct pieces, the numerator and the denominator. And I've already thought of a goal here. So I got to multiply by something to make this true. To turn a 9 into a 27, I need a 3. 9 times 3 is 27. To turn an x squared into an x cubed, I need an x. And if I do it to the denominator, then I must do it to the numerator. Easy peasy, right? 4 times 3 is 12, so cubic root of 12, x times x is x squared. Now, you can't take the cubic root of 12. Its factors are 2 and 6. You can't do anything with those, or 3 and 4. Can't do anything with those. So the numerator is done. You have the cubic root of 12x squared. The bottom is evaluatable. The cubic root of 27 is 3. The cubic root of x cubed is x. It's really not that hard, but honest to God, I'll be thrilled if half of the students get it right. Honestly, just being honest. So number 8 is a skill that 90% plus should get right. In the great state of Tennessee, maybe 1 in 3 get it right. And the thing is, you don't even know what 1 in 3 is as a percent. So there's your math skills. So if you're reading this Goff 3, there's your problem. Okay, this little piece right here is red, G, red, R-E-A-D. It's red G composed of F composed of 3. Okay, that's how I read that. Now, what does that mean? Now, what does that mean? Okay, here's what it means. It means I'm going to plug a 3 into F and plug the result into G. So when I teach this section, you'll often see me do this, and you should do it too, is I'll change the notation up. I'll make it look like this, G composed of F composed of 3, and then I'll work my way out. Now, everybody and their mama knows how to find f of 3. Well, that's not true. I can think of 2 individuals first grade who can't do it, maybe 3. I'm going to plug a 3 in right there. 3 times 3 minus 4. That's 9 minus 4, which is 5. So f of 3 is 5. So I put that right there. The new goal is g of 5. Okay. I'm going to take a 5 and I'm going to feed that piece. 5 squared minus 1. 5 squared is 25. Take away 1, you get 24. This is the final answer. G composed of F composed of 3 is 24. Hopefully 90% plus of y'all get this right. Like it should be one of those 90 other like it should literally be a skill that only one kid misses. Like it's not a hard skill. Really not. But you know, you don't like math. All right, given f of x equals 3x minus 4 and g of x is 4x minus 3, find f composed of g composed of x and state the function's domain. So, domain is inherited from the seed. And here's what I mean by that. It's g of x that's literally getting seeded into f. It talks about finding f composed of g of x. It's talking about finding f of the square root of 4x minus 3. This means that every x in f becomes the square root of 4x minus 3. And it's also the seed. So let's talk about the seed's domain. For the square root of anything at all, the stuff inside has to be greater than or equal to 0 because the smallest real number you can take the square root of is 0. A lot of domain is common sense in math, but you kids don't have any common sense when it comes to math. So you have to memorize things. 4x minus 5 has to be greater than or equal to 0. 4x has to be greater than or equal to 5. X has to be greater than or equal to 5/4. That's the domain. Okay. Now I actually need to find the composition. So I'm going to take my root of 4x minus 3 and I'm going to put it in that x. I'm going to have 3 roots of 4x minus 3 and then take away 4. It's not hard. It should be a 90% plus skill. We'll find out though. Domain of f of x is 0 to 4, and the range of f of x is 2, 12. State the domain and range of its inverse. This is read the inverse of f of x. It is not read f to the negative 1 x. It's not read that way. So you need to memorize something. You need to memorize that inverses swap domain and range. That's what they do. Inverses swap domain x and range y. That's all they do. Okay. So when I talk about the inverse, its domain is 2 to 12. And its range is 0 to 4. All right. Number 11, if f of 4 is 8, what is the inverse? Okay. So remember that inverse is swap x and y. This was x, this was y. This is function notation. But what we've done is we've swapped. It's got to be a 4. It's one of those easy questions that bugs a lot of kids. Graphing. And you have to do some conversion. And you will not have a TI-84 at your disposal. So graph y equals 2 cubic roots of 8x plus 16 minus 3 using this form. Before we do anything, we need to talk about the mama function. The mama function would be the cubic root of x. And the cubic root of x has 3 key points. 1, 1, 0, 0, negative 1, negative 1. And she looks a little something like this. So the kid's going to look the same, but it's going to be a little different. Okay? Now it says you have to factor before you can do anything. So 8 and 16 are both divisible by 8. That'll leave me with x plus 2. All right? And then minus 3. Now let's take a closer look at this piece right here. Okay? This piece right here can be thought of as the cubic root of 8 times the cubic root of x plus 2. And the cubic root of 8 is 2. So we have 2 cubic roots of x plus 2. Now, let's bring back the stuff that was already there. I already had a 2 out front, and then I had a minus 3 at the back. 2 times 2 is 4, so 4 cubic roots of x plus 2 minus 3. So your form, a cubic roots x minus h plus k. So a is 4. We do a lineup process here. H is negative 2, k is negative 3. On my graph, I plot these 2 points. This is an ordered pair. It's negative 2, negative 3. I go back 2 because I always go opposite, and I go down 3 because I always trust the sign. That is essentially the new origin. A we can think of as initial slope. Okay, so instead of rising 1 and running 1 coming out of the origin, we're going to rise 4 and run 1. Which means I'm going to have to be about right here. And instead of falling 1 and running left 1, I'm going to fall 4 and run left 1. So put me about right here. It's basically the same thing, except it's a whole lot taller. It ain't hard. It's not. It's not. I promise you, you can do this if you want to. All right, 13, you'll see that we have a square root function, so we need to talk about mama. What does mama look like? You got to know what mama looks like, right? Mama would be the square root of x. She contains 0, 0. She contains 1, 1, and she contains 4, 2, because the square root of 4 is 2, and she looks like an arm. So, of course, the kid's going to look like an arm, right? Now, we're going to have to do some factoring, just like we did before. I notice that both things in the middle are divisible by 16 again. And I have the plus 2. The square root of 16 is 4. I'm not going to go through all the nitty-gritty on this one like I did on the last time. So I evaluate that piece. And then I go through things, okay? I got to line up with a square roots of x minus h plus k. I think about what things mean here. Like that negative 2 right there is a right 2. The plus 2 is an up 2. This would be initial slope, children. Didn't ask for transformations either. So I'm going right 2, I'm going up 2. You don't have to do this, but I like to draw this in. I don't know why I haven't been doing it with y'all all year. I draw that in. And instead of rising 1 and running 1, I'm going to fall 4 and run 1. So I got to fall 4 units. I need 2 more, 1 over here. Fall 1, 2, 3, 4, run 1. And there is my taller upside down arm. Easy peasy. Let's see here. Shown as a graph f of x, state the domain and range for the inverse of f of x. Okay, so let's talk about the domain of f of x. Okay, the domain is going to be 2 to infinity. It's the x values, 2 to infinity. Now let's talk about the range of f of x. The range would be a low y value of 3 rising forever to infinity. Now, inverses swap domain and range. You write this as many times as you need to write it. Inverses swap domain and range. That's what they do. They swap them. So when we talk about the inverse, red again, the inverse of f of x, its domain is the old range. Its domain is 3 to infinity. Its range is the old domain. This will be missed by so many kids, it's not even funny. Like, stop, man. Give me a win here, children. Like, study, learn, figure it out. I cannot be the only one who wants you to learn. It's going to take both of us to do it. BRB. All right, so while I was paused, I wrote some stuff down, and you should probably do it too until you have it memorized. Inverses swap domain, which is x, and range, which is y. And the line of symmetry for all functions and their inverses is y equals x, which sadly 1 in 4 kids cannot graph y equals x. It is so disappointing what you guys have become. What the human race has become is just, God, it's bad. This is y equals x. It has a slope of rise 1, run 1. Okay, so this is y equals x. That's the line of symmetry. That's the hot dog line. That's what we fold over. Now, if we look at function f, we've got negative 3, 1. Okay, so let's just make a table for f of x. We have x and we have y. We have negative 3, 1, and we have 0, 10. Her inverse will swap these things around. X will become 1, y will become negative 3. X will become 10, y will become 0. Sometimes you need a plain old boring table. So I go right 1 and I fall 3, and then I go right 10 and I don't fall. And think about how this curve needs to look to be true. It needs to look a little something like this. And maybe you can see how it's been folded over, okay? Not a hard problem. All right, use the graph below of f of x equals 1.5 absolute values of x minus 3 and g of x to find the such and such. Now, when you see absolute value, and that's what this is, it's absolute value, you think a v. So that means that this, which is red on my piece of paper, is f of x. When you see x cubed, you think this guy, right? Because you know your mama functions. So this is g of x. Now, let's try to comprehend the question here. F of x less than g of x, okay? So what does that mean? There's so many of you that, like, you just can't read math to save your life. It means, where is the graph of f of x below the graph of g of x? Okay? So remember, f of x was the v here. Now, when we talk about that, we're actually talking about the x values, okay? So long as you're stuck between an x value of 3.458 and 8.59, it's true. What's the difference between A and D? Okay, which is a big thing. If you look at A has brackets, right? So A has brackets. Brackets imply equality. That's not what the question was asking. It wasn't. All right, now let's look at choice number 2. Should be easy. Where do the graphs of f of x and g of x intersect? Because that's where they're equal. And specifically, we want the x values. That's what we want. We want these x values. So it shouldn't be a hard question. By God, it will get missed by 25% of my students. I do not know why you miss it. I honestly don't know how you're capable of breathing. I don't. It's the x values. Literally don't know how you breathe. I have no idea how you figured out how to swallow. None of that. Hadn't figured it out. Over what intervals is the graph of f of x shown below increasing? Over what intervals is it decreasing? Increasing literally means uphill slope. Decreasing means downhill slope. When we talk about intervals, we mean the x values that make it such. So let's talk about increasing first. The graph is going uphill from here to here and here to here. We talk about our x values. X starts at negative infinity, stops at 0.2137. So negative infinity to 0.2137. But there is another section, union with this piece, which starts at 3.11963, and it moves right forever, so it stops at infinity. All right, decreasing. This isn't necessarily a Unit 5 question, by the way. It's just something old. That's one of the things I think that gets kids with me is I like to talk about old stuff a lot. It starts here and stops here. The x value that makes it start is 0.2137. And the x value that makes it stop decreasing is close to 3.11963. Okay, so 18 is inspired off of your last test, which you guys did miserably on. Miserably. Probably the worst thing I have graded in close to 3 years, to be quite honest with you. And, you know, I know some people will say, well, that's a bad reflection on you. No, it ain't. I saw what y'all did. It ain't a reflection on me. Of course, truth is, you know, nationwide, 70% of the students have missed this question. So, weird zeros have conjugates. I'd call this weird. Its conjugate is 1 plus 4i. You know, I guess we do need to take better notes here because evidently we just don't want to remember stuff. To form a conjugate, a kid say, I don't understand. Do what you're told to do, man. To form a conjugate, change the sign on the ugly part. Okay? Negative 4i, not even real. Called ugly. All right? 1 plus root 3, the root of 3 is the ugly part. It's 1 minus root 3. So these are the remaining zeros. Okay. Now, it says, what is the least degree of a polynomial? Okay. Easy. The least degree of a polynomial is simply the number of zeros. None of this talks about multiplicity of the zero. So if I can count, which I didn't do well on the last quiz, I will notice that I have 1, 2, 3, 4, 5 zeros. So if I have 5 zeros, I have a 5th degree polynomial. 1 in 3 of you missed this question on the last test. 1 in 3 of you. Now, if you got this right, you're probably like, wow, they're special. Yeah, they are. They sure are. Okay, and that's the first part, because now we're on the calculator part. Hope you enjoyed the first part. This is going to be next Wednesday when you take the first part. Be ready.